Welcome to the first and perhaps one of many symposia on societal implications of robotics here at Brown. I'm Bertram Allen, and I'm a co-organizer with Michael Littman, who's over here. And you see from the way we've dressed up, we have a lot of respect for all of you. We're very excited about this conference. This symposium is one of the many activities that the HCRI, the Humanity-Centered Robotics Initiative, lovely new banner over here, is organizing. We're a group of faculty and also increasingly students, postdocs, and colleagues from other universities across a number of departments and schools and disciplines who are dedicated to robotics as an innovative and societally beneficial technology. Some of our common commitments include to identify societal needs that robots might be able to fulfill, to advance science and technology of robots that actually do fulfill these needs, and to study and integrate into actual design the societal impact of robotic technologies. The HCI tries to enable communication among people from multiple disciplines, collaborative research, from really cognitive science to computer science, engineering, mathematics, from biology to the medical sciences and public health, from archaeology to geosciences, economics, philosophy, and law. We're running a really truly multidisciplinary speaker series, have started to create new courses, organize community activities, and reach out for external funding. In the next few years, we plan to hire an associate director, a number of postdocs, support students, and create a new laboratory for the study of human-robot co-living. We also will start an internal seminar, and we'll try to take steps to address some of the threats to labor, equal access, and diversity in this growing and fast-growing business of robotic technology. We also hope to work with politicians to the extent that they listen to us, and companies and other universities to instill activity and excitement to possibly make Rhode Island a somewhat more visible hub for innovative technology, but technology that puts humans and their needs and benefits at the center. As I mentioned, Michael Littman and I have organized this conference, but it would not have been possible without the help of three people. Tristan Baracco from the Office of Vice President of Research. Tristan, where are you? Here he is. Suzanne Alden from the Computer Science Department. She's still shuttling people back and forth, probably outside. Well, thank you remotely. And Jesse Polemus, who's also helped us with a number of the public relations. I guess I shouldn't blame him for the turnout here. Well, we have many people signed up, so our panel members will meet 30 more people who have signed up. Now I will introduce our first keynote speaker today, Professor Illah Nourbakhsh, very briefly. Professor Nourbakhsh is the director at the Robotics Institute of Carnegie Mellon University. He earned his bachelor's, master's, and PhD in computer science from Stanford University. Good choice. In 2009, he was named the Kavli Fellow of the National Academy of Sciences. And he wrote a remarkably readable and really eye-opening book, Robot Futures, that introduces people both to some of the technology in robotics and some of the very important questions of ethics, labor, societal concerns that come along with this technology. He also runs a blog in which he further addresses some of the questions that follow from this book. He has created an Ethics in Robotics open course webpage, and he's engaged in many other educational and community efforts, recently writing a book on parenting for technology futures. That's, I think, a very interesting new topic that people haven't talked much about. Professor Nourbakhsh's research has focused on exploring human-robot interaction with the aim of creating, as he says, rich, effective, and satisfying interactions between humans and robots that lead to collaboration and learning really on both sides, I would say. He has also worked on visual sensing, event interpretation, robot navigation, and really representing the ideals of the HCRI, he integrates design-based thinking and robotic innovation to achieve positive societal impact. So I'm thrilled to have Professor Nourbakhsh here. Welcome.
Thank you. Well, thank you. We can make this intimate. You're welcome to come down a few rows. It's just fine. You can wander in and out, get some coffee, and then come sit further down. You can use that as an excuse for more coffee. So I'm really pleased to be here. I hope that you will interrupt me with questions, so let me encourage you from the beginning to do that. And I'm going to attempt to talk a little bit about all three of those issues, even though I'm not an expert on any of those. But what I'm trying to do is bridge disciplinary gaps. And in so doing, I'm trying to learn as much as I can about a number of other disciplines. And in fact, I'll end with a list of books that I propose for summer reading that I think can be helpful. Now, a good place to start is to think about how, where roboticists came from, especially roboticists around about my age. And it's interesting to see where we came from because it'll help you understand a certain kind of gap that we face. So my generation of roboticists had these things in the movies. So we saw robots as these somewhat good-natured fellows that help people. And that reality that was in the movies as we got our degrees had nothing to do with the robotics we were doing in college. So the systems we were planting and designing were things like pick-and-place machines. That's what I worked on. Pick-and-place machines for microprocessor chips. Meanwhile, that's happening. And of course, that changed, right? We started getting movies more like that. And on the one hand, you can have Astro Boy or Atom Boy robots that fundamentally represent the idea of technology helping people have more insight on humanity, helping us with our humanity. And in the other case, robots that have become runaway phenomena that are trying to quash humanity for the sake of humanity. So they got some weird instruction, like an iRobot, to protect humanity, and they decided to kill us all because that's the best way to protect us. Always part of some theme in Star Trek, Star Wars, or Terminator. So those are, in a sense, the common ground that we had with the publics. And yet, if you looked at the robots that we were producing, they were highly limited. Either they were control systems for welding robots, hidden behind a chain link fence, therefore completely separated from humanity. In other words, we created physically compelling spaces in which humans and robots were defined to live different, to not even touch each other, to not even enter the workspace of the robot when it's on, when it's active. That's the world in which we lived. And if we were doing research with educational robots, we made small concrete mazes. And you can take small concrete mazes, you can scale it up and do some serious research. You can make really big concrete mazes. But it's still a world separate from the human. The humans sit in the chairs on the outside and cheer the robots on as the robots do some task inside. And fundamentally, the artificial intelligence, the planning, the multi-robot communication and coordination that my generation worked on was for robots in a world designed and built for the robots to operate in, without regard to the direct interaction and coupling between those robots and humans. And without regard to the idea of those robots breaking out of that artifice, out of that fabricated world, into a physical world, where they encounter us, people who have not been trained to interact with those robots, and where they threaten us by taking away jobs from us in ways that we never imagined before. So there was a gap, a very, very fantastical gap between our understanding of the focus of our energy as robots and what has come to be now the way in which robots have ramifications on society. I point all this out because the training we received at places like Stanford were about how to do that. They were about algorithmic optimization, machine learning, artificial intelligence, computer vision. They were never about science and society, values and technology, ethics, business ethics, law, and robotics. None of those were subjects that we had classes on. And I think it's really important to understand that gap. Of course, gradually our robots started breaking out of those walled worlds. I myself built robots with vision systems and then would challenge my friends' children to convince the robot to fall off the patio. So they'd play with it. And you started to see fundamental interactions between humans and robots for the first time. And that went further and further. We built museum robots. And even the museum robots, we started to see the hints of some ethical issues. This was the robot we put in the museum for 10 years to show long-term durability of an autonomous robot. It gave tours in a dinosaur hall. Dinosaurs, because that's good irony, right? You have a very new technology in a place filled with very old bones. But what's the robot doing? It's wandering around with people, showing them the dinosaur bones, providing them with video anthologies about the dinosaurs. And the result of this activity in the museum was that the museum docents started hurting the robot. Now, this is interesting because the docents are volunteers. They're not even paid. And yet they felt completely threatened by a $300,000 robot. Because this knowledge worker was getting in their way in the relationship that they had had with humans in that space. And they hated it. And over the course of a couple of years, we changed our tack. And essentially made the robot and the humans team. And the way it ended up working was that the docents in this case ended up in a situation where they'd talk to a child and say, oh, are you interested in archaeology? Well, if you go to that stop and then push the green button on the robot, it'll show you a video of an archaeologist. So what the docents ended up doing is becoming more knowledgeable about the robot than the visitor would have been. And then they, as a provider of knowledge to the visitor, felt like they were in a good positive power relationship with the visitor. So there was maybe a sort of a truce that we found back then. But it was an uncomfortable truce because it was quickly obvious that with AI, we can immediately start doing things that somebody loves to do. Somebody who's 75 years old is happily going to the museum every day to volunteer their services, and now there's a researcher with a technological artifact doing what they were doing. What's the story behind that? And that I think is very important. Of course, robots have broken out further and further into society, and that's where we get to this thing that in my book I call robot smog. You know, this is 10 years ago. This is old news. I went to the park about a month ago. By the way, yeah, I should mention, what's interesting is you get to watch things like violence now, right? You get to watch robots being kicked by humans. A very odd thing to watch. And you have to understand from the public's point of view, not from a machine controller point of view who's thinking about stability and dynamics. From the public's point of view, it's the violence that they see, not the really cool kinematic control that they see. But what's interesting is, you know, I went to the park about 2 months ago with my kids to the bus stop. And our bus stop is right in front of the park. There's a drone hovering in the air. Now, just one of those little four-blade drones. And I'm looking around, and I don't see any people. So what do? Do I stand beneath the drone at the bus stop with my kids? Drone overhead. Do I stand far away from it because I don't know its intentions? I don't know its level of autonomy. I don't know who's controlling it. I don't know what they intend to do with it. Do I go up the hill? There's an awkward grassy knob. Do I walk up the grassy knob and go around the robot to get to the other side where the bus stop's supposed to be? There's no idea, right? And I'm a roboticist, and I don't know what to do. Imagine what the general public thinks. The idea of robots running through the forest, in fact, the idea of quadcopters flying through a forest and avoiding the trees, and by the way, that's already being demonstrated at Carnegie Mellon. That's not philosophical meanderings. It's real. It's coming. It will be here. We have many instances of drones in the air around Pittsburgh. The police have politely asked people to land them when they're viewing the baseball game from afar. But that's new. It's a new kind of what I call smog that we face as a society, where technology has been unleashed into the hands of many without any due discourse about the limitations or controls we want for technology. Even the communication design to understand the underlying intentionality of the technology. Because after all, when I see a robot, I can't even tell if it's remote controlled or autonomous. It gets even more interesting when you think about human identity itself, and particularly when you think about the idea that we're headed toward a future where robots will in some cases be difficult to distinguish from people. When you see a truck being driven by a person in a suit, will you know that that person in the suit is a human being in a suit? Or if you can't see their eyes, could they be this machine? Could this fool you in the right circumstance? Or at least have you question the identity of it? And what does that do to the relationship you're going to have with truck drivers in general? If you go to a construction site and there's a whole lot of front loaders, will your relationship to the front end loaders be different because you don't even know whether they're being controlled directly by humans, indirectly by humans, or directly by robots? Keep in mind, there's no outside obvious indication when a robot is under remote control with a human brain, a cognitive brain behind it, versus when it's under autonomous control. So you see a car on the road. Is it being driven by a human? If the human waves you on, is the human actually driving the car, or is he just sitting there waving you on politely, but there's an autonomous car driving? Is his wave, in fact, artifice, a lie? Could he wave you on, robot doesn't see you, robot runs you over? Who's at fault? So how do you even know who has control over a system? And that, I think, is a really interesting direction that we end up in. My friend Ishiguro's robots are designed to look like humans. This is where we are headed. And yet, those robots could be teleoperated, or they could be in autonomous modes of control. And you will never know which one you're in. And it will become only more difficult over time to know which mode it's in because of the sophistication of artificial intelligence algorithms, because of how good Siri is going to become one day. What's interesting is when you ask Ishiguro about the storefront, store window display robots he's made, they're beautiful women wearing flowing dresses in like a Macy's storefront in Japan. You ask him why he makes them, he says, because my robot is a more beautiful representation of a woman with the dress on than any actual woman can be. Now, think about that. We've reached a stage where we engineers not only have entered a morass where it's questionable what the identity of a robot is, its underlying identity, but we're even willing to claim that we can design, we can create an artifact that is a more platonic ideal of a human under some condition or under some characteristics than human itself. That's something. That's a very special new place to be at. And that has to do with the idea of superhumanism or transhumanism, right? The idea that we are able to achieve something that is even more human than what humanity itself can achieve, whether you call it godlike immortality, whether you call it cognitive orthotics that make us even smarter than actual humans can be, or whether you call it beauty at a level superior to that actual humans can achieve. So there's a fundamental question of identity that you face when you start doing that, right? Identity of humanity. Is that object then that's become transhuman something that has to be afforded the treatment of a human? Or are we in the odd position of creating transhuman beings who are our slaves, and yet they're superior to us in some fashion? It's very odd. Of course, there is great good that comes out of robotics. It's even out of this kind of transhuman robotics, even out of complex, difficult decisions. This is hard to look at sometimes, but it's a fantastic example of targeted muscle reinnervation, which is a technique for accessing a large muscle group and controlling many degrees of freedom in a robot arm. This is the future, because directly implanting electrodes in the brain doesn't work very well today. And this works exceedingly well. So we're going to see a whole lot of people with very good robotic prostheses controlled by basically selecting electrical signals from large muscle groups. But what's interesting is identity here to us is clear, right? That person's identity extends to the arm, right? It includes the arm. The arm is slave to him completely. It's a robotic prosthetic. But it's actually not so simple. If it was a perfectly slaved, anamorphic recreation of a human arm, sure. He's controlling it, and it does exactly what he wants. He tells it to squeeze the ball, it squeezes the ball. But it's a little more complicated than that. It's a little more complicated. Because that arm actually has microprocessors in it. And it's not so simple as he giving the same level of primitive commands to the arm as we give to our arm. That's not quite how it works. Let me take you to the wheelchair example. We're going to make the wheelchair extinct. I wrote a blog about this. It's a very exciting and very good thing because we're going to have legs. And that's a big deal because we'll put people at eye level and we'll enable people to come here and go down those stairs without spending 20 minutes trying to get here. So that's a good thing. But you're not necessarily going to control those legs second by second or millisecond by millisecond. You might tell them to go to the nearest Starbucks. So you're going to face a really interesting future in which human robotic prostheses are in fact jointly controlled by AI systems and by humans. You could easily imagine a situation in which this arm, you tell it to stir hard because you're making a roux. And the last thing you want to do is go through the process of trying to stir really fast. So you tell the arm, please, I'm making your roux stir really well. And it has a little camera on your glasses, and it can tell exactly what's happening. So now you've become a collaborative system. You're not just a human being anymore. You are a collaboration between a human and this AI system with which you team up to do things like make an omelet or make a souffle. That's an interesting new space that we enter because that collaborative system is attached to you permanently. It's part of you. And you will feel it as an extension of yourself. That's actually a cognitive orthotic as well because that collaborative system is no longer a separate entity with which you give agency, but rather it's part of your agency. And then you can ask interesting questions like, how do other people afford agency? Do they see you as one monolithic being, or do they see you as multiple beings? Will we have a true version of schizophrenia that's different from what we think of as a phobic disease? Now, this idea of smog obviously has some very common tropes in society. There's two that I can't help but mention. One is the whole idea of making, that is fantastic because we empower people to build whatever they want, and is disastrous because we empower people to build whatever they want. And there's no way out of that, right? We're upping the ante on the power that individuals have to invent, thanks to robotics. And that power will breed what we wish to have in the world and what we wish would never exist in the world. And there's very little we can do at this point to stop that. The cat, so to speak, is out of the bag. I have to give you one specific example, because what's interesting is the way we rhetorically treat this in the press and in the punditry. This is Bumbot. How many have heard of Bumbot? Anybody in my old talks have? Sorry, Peter. So this gentleman came back from war and bought a pub and decided to make it an Irish-themed pub in Atlanta, Georgia. It was a pub in a transitional neighborhood, right between a gentrified community, Atlanta, and a former community that has some drug activity. And he called the pub O'Terrell's. His name was Rufus Terrell, so O'Terrell. So he opened the pub, and the problem he had was a whole lot of homeless people would sit in front of the pub on the sidewalk. And he believed that it was scaring his patrons away. So he had never built a robot. He was not a mechanical engineer, but he went online. He read Make Magazine. He learned how to make remote control systems. He got his old smoker, bought a high-pressure water cannon pump, bought a high-intensity spotlight, and made the world's first high-pressure water cannon, megaphone, high-intensity spotlight robot that he can threaten the homeless with on the sidewalk. This is for real. You can go today to O'Terrell's today in Atlanta and buy T-shirts that say "Home of the Bumbot." The celebration made around this in the internet blogosphere, as well as the printed press, was remarkable because it didn't go anywhere near the ethics. It talked about the idea that a common man can invent a whole new tool to solve his problem. That people can make robots today that solve an issue that they have. In fact, it demonstrated that technology itself is so inherently exciting to us. It's such a cool drug for us to take and get a high on, that the very fact that this is technological and shows a new level of innovation overtook, blinded us, really, to the desire and interest we could have had to have an ethical discourse about what it means to have robots like that in society, and what it means to have anybody who wants be able to build a robot with a high-pressure water cannon and point it at people and threaten them. And that's interesting. It's interesting that we can do that, and it's interesting that we respond as a species, as a community, the way we do. Now, I'm showing you scary fringes, in a sense, of what people can make. The second part of what I want to talk about is talking a little bit about power and the power relationship between data, corporations, and humanity. And this is going to take us to unemployment, of course. You know we're going there. We will talk about unemployment. So I have to give you an example that's easy first and then give you a harder example. Easy example. This is Hyperactive Bob. Who's heard of Hyperactive Bob? Oh, good. OK, maybe this is new. So this gentleman was a robotics PhD from Carnegie Mellon. And he noticed that short order cooking in restaurants is highly non-optimal. In particular, you're constantly cooking food that you end up throwing away 10 minutes later. Why? Why do you keep cooking French fries? You don't know what they're ordering yet. Yeah. And you can't just cook it after they order because then the line's too long. And if the takeout line is long, nobody will pull into the lot, so you make less money. So to maximize money, there's a special point. There's a number of French fries you throw away per hour to maximize your profit by making the line just the right length. Isn't that funny? Okay? Make too many and you lose money on food. Never mind you're wasting food. We never think about externalities in corporations, right? That's for philosophers. So he made a computer vision system. This is not a joke. This is real. It actually exists. It looks at the cars pulling into the parking lot and pulling up to the drive-in window at McDonald's. And it's connected to the point of sale system. And over time, it did machine learning and learned which cars order what food. Toyota Prius, filet o fish, right? Jeep Cherokee, 3 Big Macs, large fries. So it actually learned this mapping by time of day, type of car, color of car, everything it could gather. And it was directly connected to the short order cook's order screen. So what's happening is this robotic system actually tells the short order cook what to cook. And it worked. Now this is an apparent win-win-win. The amount of food you waste went down, and the wait times, the average wait times went down. So the system was able to make more money for McDonald's. On whose back? Is it unethical? What do you think? Wasting less food. So it's cool, right? It's great. We're just mining some behavioral data. and saving money.
That they are being
They don't,
classified.
do they?
Well, that's not so good.
Well, we're not classifying people, we're classifying cars. What's the big deal with that?
And the autonomy and its agency.
As for profiling the Prius drivers, you might want a Big Mac.
Oh, they can still order a Big Mac. Just slower. Another example of behavioral monetization, which starts to get into this area that we call digital labor, and there's a good series of collected works on that. That's a book that's published called Digital Labor. So reCAPTCHA. You all use this system. You go to buy a ticket. You type in the word so that you prove you're a human being. Sometimes it shows you 2 words. It used to. The reason is reCAPTCHA figured out something really smart. You're doing all this wasted work. You're typing in warped words to figure out you're human. Tell you what reCAPTCHA did. They went to New York Times and said, you guys are trying to digitize all printed New York Times archives from 1902 on. But you're having optical character recognition failures on tens of thousands of words. Tell you what we'll do. How much will you pay us for every word we figure out what it is? So New York Times give them a number. So then what they do is they show you 2 words. You prove you're a human. You're actually solving a problem. They're showing you the actual image of an OCR image that failed for the New York Times digitization process. And when your vote agrees with the vote of enough other people, they send the data to the New York Times and they collect their money. You're still proving you're a human, right? You're still proving that you can buy that ticket to the concert. Actually, that's funny. You're just spending money, right? You were there to spend money. And you're still spending money, and you're not getting a discount, mind you. But reCAPTCHA is making more money. They're not only making money from the concert master, they're making money from New York Times at the same time on your behavior. Is that okay? The world's becoming a better place, right? It's kind of like wasting less French fries. We know more about the old issues of the New York Times. And reCAPTCHA is becoming a very wealthy company. And after all, it's only a tiny bit of money from each of you, right? It's like a global wealth tax, tiny little tax. Labor tax, I should say. Oh, I don't have a picture of it. Shame. The newest thing reCAPTCHA is doing is actually, I think it's hinted at on the left there. I went to buy tickets to the Brandenburg Concertos. They played all of them at one shot in Pittsburgh recently, which is very unusual because you have to have different musicians, different instruments, different setups. So it almost never happens. So I go online to buy it, and it shows me a picture of a brownstone building and says, what's the house number in reCAPTCHA? And I'm looking at this going, wow, that's right. They finished the New York Times. They finished that contract. So now they're doing all house numbers for all houses in Street View for which you can't identify the number of the house. So I'm seeing this, and I'm thinking to myself, no, I don't want to do this. I actually don't want my brain to help them identify a house number because that individual occupant has no idea that this is happening. So I hit next, and it kept showing me more houses, more brownstones. And ironically, I tried the I'm blind button because they have an audio version. And the audio version was, you should try this next time you do this. The audio version said, type in the following 3 numbers. And I brought my wife over, and we tried it a few times. We're looking at each other going, wow. So blind people actually can't buy a ticket anywhere. It's impossible. It was amazing. That's digital labor. And what's interesting about digital labor is, of course, that it monetizes your behavior. And that's going to creep into the physical world. But before I go into the physical world with that idea of digital labor, which relates directly to technology and empowerment, it can also displace human labor. It can actually take away human jobs. And it's really odd how it can do that. The cover of my book, this isn't all of the rows. There's another row missing here in this picture. But there's 41 colors of blue on the cover of my book. So there's a reason for that. This is a true story. Google wanted the right color blue for their website. So they bring in their head graphic designer and say so. And then he comes back a couple of weeks later with a treatment, right? He shows them 2 or 3 different colors. Here's on a Mac screen, on Retina display, on a Windows screen. And they ask him, well, how did you pick these 3 shades of blue? And he says, well, I'm a designer. That's what I do. So they dismissed him. And he wrote a blog about this whole case of what actually happened. So they picked 41 colors of blue across the chroma spectrum, evenly dispersed amongst blue. So they just selected them out. And then they did split A/B comparison testing on several hundred million humans. So you would go to Google. They would choose a color blue and show that to you for your whole interaction. And you would go, they'd show you another color blue and use that for the whole interaction. And they'd got several hundred million people using each of the 41 colors of blue. And they simply chose the one that optimized a equation that they created. And we don't know what the equation was. I would guess time on task or dollars of purchases made. But that's how they chose the color blue for Google. Now that's interesting, right? It's interesting because what's happening is something that was once thought of as the sphere of influence for human aesthetic design principles, for social, interactive, aesthetic design, becomes formulaic. So you're not even doing digital labor in a situation like that to solve an unknown, to solve a problem that you couldn't solve before. You're doing it to replace something that a human used to do in a soulful way, but to do so in a highly problematized numerical way. That's interesting. And that's something that we, as a trend, are going to see in society in ever greater numbers. And I'll give you one more example like that and go on. Intel Corporation has been putting cameras on digital advertising billboards, and many other companies do this too. So the idea here is you have a billboard, and this is where we break into the physical world, folks. We can tell from about 4 or 5 meters away exactly where your pupils are looking today. But there's very good research projects now that can tell where your pupils are looking from 10 meters away, well across the street. What's interesting is the advertisement now becomes a massive sociological experiment, person by person. I can see you, I can estimate your age, your gender, your socio-demographic background. I can show you ads. And then I can look at your pupils and expression and see how you behave and respond to this. I'm connected to the point of sale system too. If you go in the store, I can see if you actually buy something. But I can do this experiment repeatedly on everybody that walks by, gathering more and more data at a level, at a rate, far exceeding what a Macy's supervisor does when they stand there with a notepad and mark up foot traffic patterns. Right? That was such a primitive system compared to this. This is massively automated, massive data mining of behavioral analytics, generating huge numbers of experiments per day. The interesting part about that is if you think about deep learning as we view it now, and if you think about this acquisition of massive behavioral data across a spectrum of different kinds of people, the line you draw is to a level of efficacy in advertisements that far exceeds what we were able to do with human aesthetic design. Could a system like that get so good at knowing how to push your buttons, and by your I mean each of you individually, that it can maximize the degree to which and the chance with which you will buy exactly what they want to sell you? Will its messaging be highly optimized like in Minority Report, but learned over time to be just right for you? Yes. There is no barrier in the way of that over time. And just like you have echo chambers in Amazon where people buy the same books and read the same, this is a center-right person, they get marketed center-right books all day long. And they keep reading them, and they echo around their head, and they become highly limited in their view. It's ironic, right, that the internet as a broad source of information, as a broad fount, makes us so narrow, because it allows us to become hyper-specialized in what we care about. But that's where we're headed. And this does the same thing for marketing decisions. So one last point about this is to ask about democracy. What happens to democracy when you face a situation in which people can be given data highly customized and optimized to them? We already have focus groups who decide what to give you, what to feed you to cause a certain behavioral decision on the democratic vote, right? Swift Boat Veterans for Truth decided to create a story about John Kerry being bad in war. They created a story knowing that the truth would come out, but realizing that if they time it right, the truth will come out too late. The election will have happened. And so it was. And so it happened. And it changed the dynamics of the election significantly, and the truth came out a couple months later. That's explicitly making decisions, right, about communication design in such a way to cause a certain behavioral response in people. That's not informing the populace in a balanced manner to cause democracy to have a chance of success through informed rational decision-making by people. That's not what it is. And guess what? This kind of robotic technology combined with deep data mining, very, very strong behavioral analysis of humans, it doesn't take us to the former, it takes us to the latter. It doesn't take us where we want to go. Okay, so I hope you're having an exciting day so far. Getting really happy and optimistic. Now I want to move to singularity. And this is an interesting one because as we talk about the future of robotics, I'm presenting you with arguments that have nothing to do with achieving human-level intelligence. It's important to understand that. Everything I've been talking about disempowering humans or disenfranchising us, is about simple increases in the success of machine learning and behavioral analytics today and computer vision. You don't need human level intelligence, and you don't need a Terminator. And yet, what the press talks about is this other thing, not what I just talked about. The press talks about immortality. Cover of Time magazine, this baby will live to be 160. Where do they get this stuff from? And I'm going to tell you one of those stories because I want you to understand the rhetoric that the press uses and how damaging that is to our ability to make decisions about the near future, the future that actually is affecting our lives and our children's lives. This is Lake Erie. This is actually a picture taken by my friend who was on the International Space Station, so it's a real picture of Lake Erie. This is not a satellite. This was taken by human hands. Probably a digital satellite, a digital camera, sadly, so not an analog camera. So this is Lake Erie, and the New York Times article I'm going to talk about was about the 2045 project. How many of you are aware of the 2045 project? Good, there should be some of you out there. Here was the story. The story was, imagine Lake Erie empty. There is no water in Lake Erie. You've drained it completely. And then in 1 year, you put a drop of water in Lake Erie. And next year, you put 2 drops of water in it. Next year, 4, then 8, then 16. So you double the amount of water you put in Lake Erie every year. What do you have after 10 years? A dry lake bed. It's a very dry lake bed. It's a disaster. So 20 years, dry lake bed. 25 years, a little bit of water in the bottom of Lake Erie. And then 45 years, it's full. And then here's the punchline now. You ready for this? The New York Times article said, and guess what? After 45 years, when Lake Erie's full, the number of drops of water you've put in are equal to the number of neurons in the human brain. That's it. And then the article goes on to say, you see, computation is exponential. It's doubling all the time. And in 45 years from start to finish, and we can take 2000 as start, that's what they did in the article, we will have human brains. Now, what are we going to do with that? That's where it gets exciting. Because then the article talked about Boris Itskov. Boris Itskov is a Russian oligarch who has a whole lot of money, and he started the 2045 project. And he says, we're going to solve world hunger, and here's how we're going to do it. We know by 2045, Lake Erie, right? So we're going to have human brains in computers. So we're going to solve world hunger by making robotic vessels, and in the year 2045, we're going to download people into the robots, thus solving the problem of world hunger. Now, you're thinking this is a load of hooey. And you're thinking when the New York Times wrote an article like that, surely they go on to quote people who explain all the technical reasons this can't happen nearly as well as he thinks. They didn't. So the New York Times did not quote people who disagreed with this opinion. They wrote it up as an exciting story about our future. And just in case you think this is a fringe dude who has a, albeit international conference every couple of years, I just want to show you a picture of him with the Dalai Lama to try and convince you that this is not fringe. There's a whole lot of very powerful people in the world who are excited about immortality and about solving world hunger by downloading human consciousness to robots. And I want you to understand that that is a rhetorical position that a lot of people in power with money have, because that puts you in an odd space. I'm guessing most of you are in my camp where you think this is hogwash, or you think downloading people's consciousness to robots in 2045 is mass murder. So either way, you probably have some ethical qualms with that. But it's important that you understand a whole lot of people, when you tell them that, who are powerful and rich, will say, no, you don't understand. This is massive. This is a big deal. And you bring up technical arguments with them about what's not possible, and they say, you're not listening, Illah. You don't get it. It's exponential. Whatever problem you're talking about, we'll solve it. And I'll say, wait. Power. How are we going to power all these robots? Right? I'm feeling so prosaic. I'm talking about power. I mean, download consciousness, we don't know how to do. But power. How do we power them all? And they go, you don't get it, do you? The robots will solve that problem because they're exponential. So they'll design new power systems. It's just like Hitchhiker's Guide to the Galaxy. It's a computer. It's going to design the next computer because humans can't do it. So you ask them about waste, and they say, no. We don't have any environmental issues by then because it's exponential. The computers will solve that problem. I'm not kidding. They say this. They actually believe all the problems that you affront to them are non-problems because the very fact that they can use the word exponential, it's like supercalifragilistic. It can make me feel good. Everything's OK. I can just say it, and I'm happy. It solves all my problems. It's a Swiss Army knife. Now, that is, I think, the fact of the society we live in. We have a dichotomy between what actually matters and what's affecting us today and disempowering us, I would argue, in significant ways, and what the press talks about and the vision people have for this utopian future. Some people call it the age of plenty. Some people call it the age of leisure. There's a book called The Zero Marginal Cost Society about how marginal cost of all products is going towards zero, and therefore we will all have everything we need without money. So it's okay that we have people who are poor because you don't need money to buy things anymore. So poverty is all right. So this is the rhetoric that you have, massively disconnected from the reality of the next 10 to 30 years of robotic technologies and the ways that they impact society. Now, we have to talk about jobs, because that's the way in which this has impacted us for the last 30 years and is going to continue to impact us. And I have to start with some quotes from a former CEO of Adept, because they're so interesting, because they again point out the disconnect you have between people in positions of power in companies who don't understand value hierarchy or ethics and the rest of us. So his point is, well, first of all, don't worry about robots, because outsourcing is worse. Good old value hierarchy, right? Don't worry about this bad thing. Look at that terrible thing over there. Then you've got the second line. Robots are used for things robots are good at. Not pointing out, mind you, that robots get better at everything every year. So that second line doesn't help us much. People are designed to use their minds. And this is a common response you will hear from people. And I'm going to show you an example of that. The idea that humans shouldn't have to do manual labor. Manual labor is for robots. We should be intellectual. An interesting comment, because if you look at the pyramid of work that we have across the world, massive number of people are employed to use their hands. And if you're about to displace all of those into jobs of intellect, I would like to ask them to explain to me where these jobs of intellect are that all these people are intended to be doing, that will actually pay for the bread that they can eat at night. It's a fundamental problem. Now, to show you the trends that have been happening, we had downloaded the entire Paris School of Economics database to the Create Lab, and we've been doing visualizations with it. We have a time-space visualization of all countries in the world from 1850 on, and you can see inequality in all those countries online, so I encourage you to look at that. These are some charts I took from Capital by Piketty and from Second Machine Age by Brynjolfsson and McAfee. But there's a few interesting things to quickly show you, and then yes, I do have some good news at the end. So starting in the 80s, what you see is median income per capita, the amount of money people make on average, has essentially flatlined, adjusted for inflation. Meanwhile, companies do better and better. So what is with that? How is it that companies can do better while people flatline? And the answer is productivity. The answer is we're getting really good at doing more with fewer people precisely because of automation technologies. And you've known this, but this chart makes it real for you. And what's interesting is recessionary pressure causes you to lay off people, right? But it does something else. Recessionary pressure causes you to invest in productivity-enhancing technological tools to replace those people, because now you don't have those people. And then guess what you do when you come out of the recession? Do you lay aside the productivity-enhancing tools and hire the people back? No. You keep the people off, and you have more profit margin. So that's what's happening. And it's interesting to note that labor productivity keeps going up even in times of recession, and that's a very important point. Now, the scariest map of all. If you compare the profit share of GDP, the amount of money generated from the productivity of society that goes into the coffers of a company, capital, versus the amount of money, the labor share of GDP, right? The amount of money that goes into the pockets of workers. Over the course of time, for a very long time actually, for something like 80 years, I believe, even longer than this shows, labor income share is much bigger than company profit share. But that's flip-flopped now. And it's flip-flopped quite dramatically, where we're on growth paths that are very steep, where the labor share of income is going down rapidly. That's not me. And the profit share of income is going up rapidly. And that's interesting, right? That's interesting because it suggests that we are going to be on a pathway toward an ever more unequal society, a society in which people who work don't make a proportional amount of the productivity received from GDP. I have a cartoon for you. It's an interesting cartoon because it shows the inequality. I'm going to go through it quickly because I want to get to another set of slides too. So I can take questions at 10 o'clock. Is that okay?
Sure.
Okay, because we have till 10:30, right? Yeah. Great, so we can have a discussion. So capital, first of all, it's a good thing, right? It's when you have a house that you can rent or you have money in the bank. How do you get capital? We start not having much capital. There's two ways to get it. You earn it, labor, and then you put in the bank, right? You buy a house. Or you have capital. If you have capital, you make money on the capital, right? You get interest on it, or you lease the house and you make money on it. Or you have a crazy hedge fund for the Kingdom of Saudi Arabia. Now, it turns out all of this is very unequal, but it's interesting how it's unequal. Let's just take labor income for a second. How unequal is labor income? The top 1% earners in terms of labor income, this is not capital ownership, mind you, this is just labor. Top 1% make about 70% of all the labor income in the US. So just to be really clear about this, that means the bottom 99% of earners make less money by a third than just the 1% on top. So think about how unequal that is in distribution, right? Massively, right? In fact, if you take the top 1% and the top 10% and you put them together, you're left with 8% left over for everybody else, everybody but the top 10%. So this is why you get Occupy Wall Street. But here's the interesting bit. Take capital income and compare it to that. For people who have capital, check out how much the top 1% make on capital compared to the rest, the top 1% owners of capital. And you'll notice here, there is nothing for the bottom 50%. So the bumper sticker here is labor inequality is horrible. Capital inequality is even more horrible. So you got that picture. Now, just in case you thought there's some fairness at the top, if you think about the rate of return on capital itself, how much money people make on capital, the rate of return varies massively based on how wealthy you are. If I have $100,000 in the bank and you have $10 million in the bank being a metaphorical term for investing capital, we don't both make 2.5%. I make a tiny fraction, even proportionally, as much as you make. Now get that. That's a runaway train. The proportional fraction of money that I make is far less than you make. So any outsized inequality magnifies massively over time. The top 1/20th of a million people in the world in capital ownership make more than half of all the interest on capital. And the top, this picture's hard to read, but the top, those who own capital make twice as much of a return on it than those who own income, capital derived from income. So now where does the robots come into this? Brynjolfsson and McAfee had a really nice line. They said, think of robots as systems that can replace routine mental activity and routine physical activity. Now what's interesting about that is that's blue collar and white collar. And the word routine mental activity and routine physical activity is a changing game. Every year robots are better at this. Atlantic Monthly article that was outstanding came out talking about machine shops along the East Coast, the eastern seaboard. And it was interesting because it talked about mid-level machinists who are losing their jobs now because CNC mills that can do the job of a mid-level machinist have gone down in price from a couple $100,000 to $20,000. Well, you pay a mid-level machinist $30,000 to $40,000 a year. So the ROI, the return on investment on the machine, is less than a year now. You can buy the machine, fire the person, and compensate for the fact that you bought the machine, like that. So they're interviewing people in this factory plant. And there's a whole lot of mid-level machinists that have been given pink slips. And there's a few high-level machinists who are keeping their jobs, right? The ones who are do much more sophisticated work. And the interesting dynamic was the owner said, look, if you don't let me hire the robots, then I go out of business. So you lose the whole company and you lose the fact that I'm an American company, or you let me get the technological improvement in productivity. You talk to the high-level machinists and they say, well, yeah, we're going to lose our job too, because the next wave of robots are $200,000, but they're coming down to $80,000 within 5 years. So they already know that their days are numbered. Then they did a very careful ethnographic study of one of the mid-level machinists and talked to her and said, why don't you go and learn more and become a high-level machinist? And she said, are you kidding? Do you know how much money I would need for school to get that degree? And I have 2 kids. I keep 2 jobs, actually. This is one of my 2 jobs. I live an hour and a half away. Here are the complex family relationships that I have to take care of my kids while I come to work and go back home. There's no time in my life to get an advanced degree. And even if I did, there would be 20 other mid-level machinists vying with me for one slot at the high-level job. So it's a beautiful article because it took an abstraction and made it very precisely real by talking about a particular person by name who lives in town and has the kinds of real problems we face in life. And it shows you where we're headed. So the punchline is that robotics is a pump. It's a pump from labor income to capital income. Every time you buy a robot, you've transformed potential labor productivity into capital productivity. And because capital productivity is far more unequal than labor productivity, which is already bad, it's a pump toward inequality, toward massively greater amounts of unstable inequality. And that's really interesting, because that suggests that, and I should mention that the definition of routine mental and physical activity that the robot can do at a better ROI than a human every year progresses. So there is nothing stopping us from a world in which we have ever greater amounts of inequality thanks to robotic technology. That's the really depressing stuff. Now, New York Times did a blog post called Robotopia a couple of days ago. All right, Shunde, China. This is fabulous. This is a place in China where they have a lot of people from other parts of China coming in and working at the factories. So you need to go to the New York Times and listen to this video. It's absolutely fantastic. The video is called Cheaper Robots, Fewer Workers. This is a China project. This is the economic minister for Shunde. And the project's name in China is, quote, replacing humans with robots. That's the name of the project in China. No kidding, not an April Fool's joke. And he talks about it. And he says, our goal is to reduce the number of employees in Shunde by half. So this is a Chinese government goal to have enough robots in Shunde to reduce the number of people working there. Why? Why do this? Why bother de-jobbing people? Current migrant workers born in the 1980s or 1990s, their endurance and hardworking spirits are inferior to the older generations. That's his answer. People aren't any good, so we want robots. We have a program of action by the Chinese government. If you start a company in Shunde and you automate the company, they give you a land grant and deferrals on your taxes to compensate you for having automation. Now, the best part, I didn't say, you got to watch the video to get to the very end. Because at the very end, the interviewer asks him, so what should the people do when they lose their job? And he says, they should just go back to the regions they came from because there's plenty of factories there. And then the interviewer says, but aren't you going to automate there? He said, yeah, in 10 years we'll automate there. End of interview. So it just leaves you hanging, right? Send them back to their home state in China. And yeah, of course we're going to automate there too. So then what? Where are we headed? So that's a depressing view on robotics, perhaps. But I think it's important to understand that robotics threatens the sense of who we are, our identity. But it also has the potential to seriously disenfranchise us. And it does that economically, it does that politically, it does that informationally. And it offers a way by which companies can have ever greater levels of productivity and monetization using our behavioral analytics in the physical world, how we walk around and what we look at and who we talk to. All of that is data. And that data will be turned into money for companies. What do you do about all this? How do you possibly prepare for this? And that's the question that we battle with for 20 years at the Create Lab. How do we create in society exemplars of robotic technology where they're explicitly empowering people rather than disempowering people? So that's what I wanted to talk about next. And I just want to show you a few examples of videos to lighten the mood and show you what we do. So we have 30 engineers, former school teachers, artists, graphic designers in the Create Lab. We are an open source lab. We get all gift funding, so we don't take any project or milestone-based money. We only take gift money. That allows us maximum freedom to do whatever we want. Every project we do is by choosing a community of practice and then inventing robotic technologies with them in a participatory way that we believe actually empowers them. And I had a few examples from education I wanted to share with you. One question you can ask is, how do you make a technologically fluent generation? How do you get kids to actually understand technology well enough to be able to invent good technology in the future? You can't, in my opinion, achieve technological fluency by having kids learn how to download apps and use them on an iPad. Because all you're doing is creating consumers. You're creating people who understand how to consume well-designed and packaged technology. For technology fluency, I believe you have to show people how they can remix technology in formerly unintended ways to tell a story they care about, to make something that they deeply believe in possible. And so Project Zero at Harvard is something I'm very, very proud of there. The idea that you slow learning down and cause observational skills to become the core of learning in pre-kindergarten and kindergarten around technology is something we work on very hard. We're doing this actually across a number of schools in the Pittsburgh area now, and have made literally wooden blocks that have electronic discrete components on them, tumbled in beeswax, local beeswax. The wood is also locally sustainably harvested. And these devices are made in a small factory in Pittsburgh by people who are on full health care. We put them into classrooms and we teach teachers how to stop telling the children the answer, but instead ask questions about technology, open-ended questions. You can't be finished. There's no I'm finished. You're asking open-ended questions and letting the children explore, draw, and talk, and develop a language, a common semantics around the ideas of technology, around serial and parallel and capacitors and buffers and LEDs. It works exceedingly well. At the end of the year, the kids get toys from Goodwill, and they take them apart, and these are 5-year-olds who now know the word Phillips screwdriver, flathead screwdriver. They take the toys apart with care because they know wires. And then they look inside and they say, oh, there's a potentiometer, and there's an LED. And then they take the alligator clips we've given them, they plug them in, and they make a new toy with the discrete electronic components inside the toy. Then we get phone calls from parents at home. I got one last year saying, hi, Susie came home and says there's a resistor in my toaster. What should I say to her? What should I tell her? So that's what you get. You get children who are no longer viewing technology as a black box, but rather as something that they can have hypothesis about and that they can use as building blocks, the way we think of clay and crayons as building blocks. So, quick video on that for fun.
I have something new for you. Close your eyes. And a teacher is going to put something small and delicate in your hand. Feel what's there.
I feel that it's rough, it's metal. I feel bumpy.
Lena.
The Children's Innovation Project started in 2010 when Jeremy was hired as a resident artist at the Create Lab at CMU, and we began work in my kindergarten classroom here at Pittsburgh Allegheny.
Both of them with wings.
So the Children's Innovation Project is an exploration of through and of technology, thinking of it as raw material, much like we would think about paint as or clay, and understanding how it exists, why it exists, and what we can do with it.
The big split switch.
Think about what electricity would travel through.
Because a good innovator wants to wonder and is curious about the world.
Simple example, but it turns the power relationship over on its head because the child is in charge and technology is a material. Rather than saying there's a right way to use this tool, this artifact, you have to learn how to use it, be careful, don't break it, and do exactly what I say. And that inversion of power, I think, is very, very important. I'm going to skip that for the sake of time. I'll give you another example called the Lemonade Project. This is one where we had some hydraulic fracturing issues in Pennsylvania that have become really out of hand. And people are worried about their water quality. And as a result of this, we've been designing tiny robotic artifacts that go in your toilet tank. They go in the reservoir of your toilet, and every time you flush, they take water quality measurements so that you have direct access to your well water's water quality. But a resident artist came along and turned that into a project with kids. So I'll let the kids talk about that. And again, think about this in terms of how it inverts the power relationship between adults, kids, and technology.
The Lemonade Project is one part art and one part science.
We use the catfish to measure the dissolved particles in the water. Then we wrote down the data, and then we put it on a sign, which we put on our lemonade sticks.
The catfish measures dissolved solids in the water. I can show you how the catfish works. You stick it in the water, you push the black button, then when the bubbles come up, that means it's thinking, and then it shows you how many contaminants it has in it. Dissolved solids could be anything. Lead, rusty pipes, or even charcoal filters that you drink out of. We live in Pittsburgh. In the past, steel mills dumped pollution in our water. That was a long time ago. But now we have to worry about pollution from fracking. So it's important to know what's in our water. Anyone, no matter where you live, you can call the water company and get a report. It's free. but it's more fun if you use the catfish.
We lured people in by our beautiful lemonade stand, and then we lectured them about the water quality.
We priced the lemonade by the different water qualities. The better it was, the higher it cost.
I got the recipe of the best lemonade recipe ever on the internet. It needed to be the best because it was one of the highest quality of water and it was the most expensive. It went from 15 cents a cup to $1 a cup.
Can you ask Lily, one is more expensive? I think it's the same lemonade. I don't know. Can you ask why?
Why? So basically, they're different water qualities. People really liked it.
They thought it was great that kids were teaching adults the water quality.
They also learned about the catfish.
Lemonade Project got people to ask the question, what's in our water?
My favorite part was being at the lemonade stand and selling lemonade and getting money.
The best part was drinking the lemonade.
Cheers! Have some lemonade!
So, inversion of power relationships. You've taken technology and turned it into a rhetorical artifact that the children are using to co-opt the parents into a discussion, right? And they're in charge. Now, they're the information sources rather than the parents being the information source. That's what I think technology fluency can bring us. There we go. Okay, I'm going to show you one more example, and then I'll stop in the interest of time because I want to be able to get some feedback and discussion going. But when you go to middle school years, this same mentality applies. Arts and Bots is a program we have. We're trying to teach children how to make robots and then choreograph the motion of those robots, but for a purpose that's a little bit different. We want to teach teachers in a middle school environment to be able to identify the talent that every child has. Now, talent theory has a problem today, which is often the case that you have specific archetypal talents you're looking for. We want to subvert that and think about the idea that every child has talent, and your job as a teacher is to find their talent and nurture that particular talent. So we have a National Science Foundation grant where we're doing this across the entire state of West Virginia and Pennsylvania. What we're doing is training the teachers in poetry class, history class, anatomy class, and physical education class. They use craft materials to have their children build robot artifacts representing core ideas in those disciplinary classes. This is not tech class. This is not computer lab. Because if you do that, you get selection bias. You get only the kids who care about technology. This is poetry class. So you read a poem, you build a robot that represents what that poem means to you, and you choreograph it. In so doing, you've learned engineering design, you've learned to build the robot, and you've learned to computer program it. But you've learned all of that in service of something you may care about much more deeply than the robot, the poem. So we believe this has a lot of legs, this idea of thinking about technology as an integrative tool in a discipline. So I have a video about that one, my last video, I promise. There's many more, but I want you to get a sense of what we end up doing.
Who would go parading in London and masquerading?
In this room, you see some of our 7th graders. They are making a robot theater where poetry comes to life. They get a poem, and they must make a roboticized diorama to bring the poem to life.
We're probably gonna have like Daddy standing somewhere around here, and we'll have a motor with like a popsicle stick or something to knock him over so he falls into the pond.
And we're trying to make a spin.
Poetry can be challenging for a lot of kids. They don't like it, they don't understand it, and so I thought this might be a way to make it more fun. How do you understand a poem? It's the repetition of the reading of the poem that helps you understand it. So when you build something, you have to really think about it. They may glean some more meaning from it.
On the last day of October, when dusk is falling.
This is a way to be creative with technology.
So there's many projects like that. You can kind of ask the question, the meta-level question, which is, what do you do? And we do this across age ranges. We have adult programs too. But you can ask, what is our checklist, right? What are the things that we think are core to taking robotic technology and imagining its use in society in such a way that it authentically helps rather than hinders our humanity? And we have a checklist with 4 things on it, so I wanted to just give them to you. Authenticity. Is the way in which you're using technology actually revealing reality? Is it a lens with which you're making something invisible visible? We have air quality sensors, water quality sensors, a kinematic device that expresses how you feel about a poem. Those are all taking something real and expressing them. We don't do pick up all the balls on the ping pong table because you have to. We don't do that because that's not authentic to a real problem that you can see in front of you. Freedom. A whole lot of technological artifacts used in educational settings actually constrain the teacher because they come shrink wrapped. Here's the binder, execute this as is. And most teachers can't do that. There is no time given the Common Core to do that. You basically put it on the shelf and don't use it. Can you invent technologies that truly empower the teacher to design their own curricula? And so in fact, for all the programming we do, we have professional development in schools of education around the state, where the pre-service teacher is trained in our technology and then designs their own curricula and their own rubrics that they take to the school when they go to school. So it's different in every school. It's never the same. It's never shrink-wrapped, and it's owned by them. They have a sense of ownership over the technology and over the deployment of the technology. Diversity, this is the talent theory side. If you use craft materials instead of Legos, we did national interviews, and people said, girls said, Legos are ugly. We don't want to use Legos. But if you use craft materials, if you allow for choreography and music and lights, if you measure water quality and air pollution, and if you make all those tools available to the teacher, what you do is access the talents that every child can have in the areas of design thinking, aesthetics, communication design, engineering design, computational thinking. So you don't concentrate on any one of those. Instead, you build something that reveals any particular disciplinary talent that a child has. And last, impact. We've found time and time again with the Lemonade project, for instance, if you can make the project about social impact literally, the kids love it. They engage with it. High school on down. They want to matter, and they want their actions to matter in the world. So make the project about an actual issue. We're doing a major Hear Me project nationally right now around school funding reform. We have major issues in inequity in school funding across the nation, number of dollars spent per student. They're learning to use very interesting robotic techniques to capture audio and make sculptures that tell the stories of school funding. But it's for school funding. It's for an issue that they care about deeply, because 50% of the kids in our school, in our public school system today, 50% are in poverty. And nobody knows that. 50% are living under the poverty line. And they're sharing textbooks, right? You go to school in West Virginia, there's 15 textbooks in physics. There's 20 people in your class, there's 2 classrooms, they have to share 15 textbooks. And they can't take them home to do the homework because there's only 15 of them. So in school, you have to find little gap times to look at the book to try and learn enough for the test. That's the reality of education in America right now. When you give kids the voice to be able to tell that story, they will eat up technology in service of telling a story that they care about deeply. So that's impact. Okay, I promised reading list. So here's a quick reading list to leave up. Books that I recommend. Yes, I put my book up there, I'm sorry. I brought a couple of copies of Robot Futures. I also brought a bunch of copies, a couple of copies of Parenting for Technology Futures. That one I self-published, so it's as cheap as possible. So that one's only $2. It's Amazon's real-time publishing thing. But there's some interesting books here. Mindless by Simon Head is fascinating. It shows you how Amazon workers are being roboticized. They track their movements and then train them to move just right to be able to pick up boxes and pull out boxes faster. So people can move more boxes per minute. So they're training human bodies to move faster, to be more robotic. It's a really interesting story. And then I think Digital Labor is there. It's a collected set of readings that are useful and interesting because it gives you a sense of all the ways in which corporations can monetize human behavior. So with that, let me invite you to provide comments and questions back.
Usually the acoustics in this room are good enough that people can ask questions like, clear enough without having to go to the microphone.
So first of all, thank you for a great talk.
Thank you.
Lots of these points resonated with me very well. And I feel bad about asking this question. But I want to push you a little bit on the point you made of labor shifting more so to capital based on robotic technology, which is very, very apparent. How are the efforts that we're trying to put into STEM education, right, and and getting kids to think about mechanisms and computational processing and so forth. How are they going to change that?
So it's really interesting. The PCAST, the Presidential Commission on Science and Technology, did a report on STEM learning that's worth reading. But their whole rhetoric is that we have a STEM pipeline that needs to be filled with people, that we don't have enough STEM-educated humans. And it's nonsense. What's interesting is, if you look at the demographic analysis of things like gender and racial gaps in income, it's just as bad in STEM fields as non-STEM fields. Nothing about STEM equalizes society any better than any other field. So one issue I have is the whole STEM approach that leaves out things like history is crazy. We've left out English and history for reasons that don't make any real sense. Now, having said that, I'm doing all these programs where I am introducing technology into children's hands. Why am I doing that if I think technology is evil? Well, mainly because I want a whole bunch of people who are right-minded in their approach to technology. I believe that if the innovation in our society could come from people who believe that technology is supposed to empower citizenry, then I believe we could have a generation of technological artifacts born of society that aren't having the dystopian consequences that we're visualizing right now. And yet, you're absolutely right that the trends we're seeing right now make it seem like a STEM education isn't necessarily that useful. The right education might be humanistic education, because those will be the kinds of jobs that are less likely to be replaced by robots in the near future.
You could flip the argument and say, if you educate more people to do more robotics work, you're going to accelerate that process, right? It's going to get worse faster.
So you definitely
said it's refrain from pushing the technology, right?
Well, I think knowledge is good. I think that the best thing you can do is educate them the right way. So the idea that I can get a robotics degree at Carnegie Mellon or Stanford and not have a single lick of ethics training and never study the Industrial Revolution. I've had faculty colleagues of mine, when I'm giving a talk, say, well, it was fine the first time around. We went through the Industrial Revolution. It was all fine. That means they've never heard of the famine and hunger from 1820 to 1890. They have no idea about the number of people who starved just because of things like automated looms. And are they saying that the same multi-generational thing is fine now because 5 generations from now we'll figure out a path forward? No, it's lack of historical knowledge. So I think fundamentally we need more knowledge, not less for the kids. But it's a good question. It's a good point. Other comments? Yes?
Follow on your STEM education. STEM is STEAM, string, STEM cubed, STEM squared, STEM.
Yes.
Somebody's going to come up with a great acronym soon. I have the opportunity to work with schools throughout the United States. And what I've seen now is the insurgence of robotics coming in due to STEM, and that funding due to STEM, where we may not see robotics in the schools had we not had these STEM initiatives. Now, my question to you is, how do you see the competitive robotics? Because that's the comfort level right now in schools. They're going towards the competition, whether it be VEX or Lego or Best or First or whatever. That's that in the career and technical education, that's the justification for putting robotics in as opposed to putting the robotics in for teaching academics or teaching literacy. So where is that balance, and how is the competitive portion of it positive or negative with the schools?
So my personal view is that the competitive portion is positive. I saw lots of excellent people in my school growing up who did things like Science Bowl, and they prospered because of that. They had a competitive spirit. The thing to remember is that you will suffer from selection bias. Those competitive systems are generally informal out-of-school learning experiences. Any out-of-school learning experience fails to engage all of the folks that are in poverty. That's half the school right there is just unengaged completely. So typically they're great, but the selection bias is there. You're helping exactly the students who will do just fine. And the interesting question we face as society is, what do we do for everybody? What do we do in a truly just and equitable way? And that, I think, is hard, and I think competitions don't serve that purpose. Yes.
I'm Daryl Stahl. I'm an 80-year-old retired priest who has a 14-year-old grandson who's in a robotic club. And he asked me to come and see the convention he was going to. I thought, how dare. 5,000 students showed up.
Yeah.
But he comes from Duxbury. Duxbury decides they want to do things for their kids in the technological age, so they go hire a superintendent who specializes in that. Your whole argument about the elite are going to get more elite. That's the other thing is that I have read both The Race Against the Machine and The Second Machine Age.
Yeah.
And both of those are quite positive in the end. You seem to have much more of, I'm an Anglican priest, and we, first of all, teach the creation was good, and then we have to work with the fact that we seem to be alienated from ourselves and from each other and from God. Those two things have to dance around somehow. And you're very much aware, from what you've said, about the fact that we can take something that's wonderful and misuse it in ways that we can't even believe now. I saw that Putin is going to go with robotic warriors in the next 5 years.
Yeah, that's right.
Maybe that you've heard about that too. So I know people can take something absolutely great and really do crazy things.
Let me comment on those two books. It's really interesting. I've talked to both of them. I have the pleasure of being at conferences with both of them. And Race Against the Machine is interesting because it talks about some of these dynamics of employment and machine, and ends up by saying, but our way out is innovation. If we can be clever as society and innovate well, we'll create whole new job categories, just like iPhones of the future, and that'll solve our problem. Race Against the Machine did that. Second Machine Age is I'd say 2 ticks less optimistic. When I talked to Eric and Andy today, they're another couple of ticks less optimistic. So I believe that they've seen the writing on the wall on that. And they started, I think, trying to be optimistic, but they're seeing that innovation is not necessarily inherently a way out. Good comment, of course.
Washington had a conference yesterday on inequality, centered in South America. And then they had 4 or 5, maybe 6 really high top-notch people like Anderson from the New Yorker and Porter from the New York Times to talk about these issues. And what they all said, you economists have to tell the story in a narrative form because people don't understand economic thinking, and they really are suspicious of you. So we got to do something about that. But one of the things they did have a little bit hope on, they said maybe people might start think of participatory capitalism. Have you heard of that?
Yeah, there's a. Well, there's at least 2 or 3 theories floating around, and I just posted one. So unfortunately, I've added yet another theory through a HuffPost blog. One theory that's been around for a while is the idea of capital ownership sharing, that every time people lose their jobs because of a robot, they should have fractional ownership of the robots, of the capital. Another idea, of course, that Thomas Piketty made pretty popular recently is the idea of a global wealth tax. Good luck with that. That's a global tax on capital that all countries would have to agree to, so that's challenging. The thing that I put up that people have also said in the past, I didn't invent it, is the idea of a price duty on goods based on the amount of automation in the goods equal to the productivity differential between the machine-made good and the human-made good, to make it equally profitable for a company to choose to use humans or machines in an attempt to get people to have a justifiable reason, even if you have a public share price, to actually use humans. What's interesting is there's a fourth way, which has been very successful in its own right in South Africa and Japan as examples, which is a heavy touch service economy. If you go to Japan and you go to department stores, there's many more people than you need there to provide excellent levels of service. If you go to South Africa and you go to the gas station, there's 5 times more attendants than you would ever imagine in an American gas station. They're there precisely because the governments want to have high-touch service. Because high-touch service, human-to-human contact, is a very good technique for employing lots of people. You go in the street and you see street sweepers in Japan, and there's 8 street sweepers, humans, pushing push brooms next to each other to sweep the street. Of course you could have had a machine do that, but you don't. You choose not to as a society precisely because you want to employ people. That, I think, is a really interesting fourth path, but very few countries in the West take that on. Yes?
I just want to push back a little bit on your thought about that you just made us a few questions ago about the Industrial Revolution and how terrible things went. I mean, I think that the Industrial Revolution is credited greatly overall, increasing the quality of life for the entire, not for the entire world, at least for the developing world, the developed world. And to that same extent, I'd like to also point out that a lot of economists often do that there is wealthier
happier now, we're healthier now, we're self-reportedly, admittedly, happier now than we ever have been in recorded history, as far as we know. And so I'm a little trepidatious about the parade of horribles that you're kind of like, you're putting out there about if we don't have this knowledge about these robots, if we don't jump on this and aren't aware of everything that could happen as it's happened in the past. I wonder if that's actually like a completely holistic narrative. I wonder if that really takes into the account that maybe there isn't something that we can, there isn't something right about the idea that some of these problems, there are going to be problems with any technology, and as the problems present themselves, the most efficient mode of dealing with those problems will be taken on by future generations.
Yeah, it's a very good point. And indeed, our quality of life has gone up significantly. Average life expectancy has gone up. The fractional necessity for farming has gone significantly down. Quality of food has gone up. So the problem that I have is the fallacy of disconnecting long view and short view. People seem to say over the long term, there's outstanding positive impacts, and I completely agree with those. What people forget is that there's short-term, even though they're short-term, they're cross-generational negative impacts on society that occur. That's documented. It happened. It'll happen again. And robotics, over the long view, theoretically can improve quality of life. Of course, it can extend our life expectancy in ways that are unimaginable today. What I'm interested in is that we seem to forget the short-term impact it can have on things like unemployment and inequality, because we're looking at that faraway great place that we might be headed toward. The second problem I have is the calculus of decision-making around how to make those robots positive on society. I'm worried that the capitalist and government-based system of decision-making around which technology to support, which technology to forward, isn't necessarily in the best interests of individual human beings. I get that Industrial Revolution did cause individual human beings en masse to benefit several decades later. I get that. I understand that. But I'm worried that in this case, the profit motive that exists in companies is so strong, in fact, so overpowering, that it may manipulate the downstream effect of technology decisions we make more than we would wish, so that we end up not going down the best possible path, even for the long view. And that's just a hypothesis. I can't possibly prove that. But I think we need to be more worried than we are about the next 5, 10, 15 years, and stop talking just about what coolness we're going to have in 60 years. That's my concern.
So we are running out of time here. I want to thank our speaker, Professor Nourbakhsh, and there is still some breakfast, I think, up there, if you want to catch something before you leave. But again, thank you very much.
Thank you.